Hey, magandang buhay. So, ako si Sir Ben at narito ako upang i-discuss yung mga word problems that involves circular functions on real numbers. Okay? So, let us start with the first one. So, we have here, if P of theta is a point on the circle and theta is 5 pi over 6, what are the coordinates of P of theta and determine the values of the 6 trigonometric functions. So, we have two tasks to do here. First is to identify the coordinates of P of theta, and we are going to determine the 6 trigonometric function of theta. So the first thing to do here is to identify the angle itself. Isn't it that the angle here is 5 pi over 6? Personally, what am I going to do here is to express 5 pi over 6 into degree measures. So 5 pi over 6 is actually equivalent to 150 degrees. Next thing to do here is to identify the reference angle of 150 degrees. 150 degrees is actually located in the second quadrant, and the reference angle of 150 degrees is 30 degrees. Okay? So, if we're going to illustrate that, if we're going to illustrate P of theta in a Cartesian plane, it would be something like this. We will have a right triangle here. This would be the point itself. Theta would be here. Now, theta, we know that that is equivalent to 30 degrees. This part, this is equivalent to 30 degrees simply because this is the reference angle of 150 degrees, which is theta. Okay? So, this is 30 degrees, and going back to the lessons in grade 9, we know that in a 30, 60, 90 triangle, the opposite side of the angle that measures 30 degrees is equivalent to 1. The hypotenuse of that triangle is 2, and the side opposite of the angle that measures 60 degrees is square root of 3. But since in this topic, and this one involves a unit circle, it means that the radius, this is the radius in this unit circle. Okay, so again, try to use your imagination. This is actually a unit circle, and this is the radius itself. Now, in a unit circle, the radius is equal to 1. So what are we going to do here is to divide each side by 2, so that the radius would be equal to 1, as you can see on our screen. Now, the measurement is not yet done. This part of our Cartesian plane, we know that this would be negative because this side is the negative part of the x-axis. Now, if this would be the point, we can now already, if this is our point, we can already identify the coordinates of that point. This is the value of x, and this is the value of y. Therefore, the coordinates of P of theta will be negative square root of 3 over 2 and 1/2. Okay? So that would be the coordinates. Next, how are we going to determine the values of the 6 trigonometric functions? This would be easy. So as long as we know what is the value of sine, cosine, and tangent by using the shortcut that we memorized, that we remember, the SOHCAHTOA. Okay? Isn't it that sine is equivalent to opposite over hypotenuse? The cosine is equivalent to adjacent over hypotenuse, and tangent is equivalent to opposite over adjacent. So again, looking at our figure, this is our angle. So this would be its opposite, this would be its adjacent, and this is the hypotenuse. So sine 30 degrees or sine theta, that would be equal to 1/2. Now, we all know that the reciprocal of sine theta is actually cosecant theta. So what am I going to do here? Personally, what am I going to do here is, since I already identify the value of sine theta, I'm just going to reciprocate that one for me to already identify the value of cosecant theta. And in that case, that would be equivalent to 2. Next, cosine theta. Cosine theta, that is adjacent over hypotenuse. So in our figure, that will be negative square root of 3 over 2. Reciprocating that one, definitely, that would be 2 or negative 2 over square root of 3. Rationalizing that one, we will get the value of secant theta. And secant theta is negative 2 square root of 3 over 3. For the last one, tangent theta. So tangent theta, that is opposite over adjacent. So in this case, that will become negative 1 over square root of 3. Rationalize that one, we will get negative square root of 3 over 3. Next, for our cotangent, definitely, we're just going to reciprocate this one. So we will get negative square root of 3. Okay? So in rationalizing, if in case you forgot on how to do rationalization or rationalizing the denominator, you may watch the video that I've uploaded about the about that topic. Okay? Let us proceed to the next example. So we have here, if cosine A, so A is an angle, cosine A is greater than 0 and tangent A is equivalent to negative 2/3, find the value of secant A plus tangent A all over secant A minus tangent A. So, how are we going to deal with this one? First, focus on the given. Cosine A is greater than 0. That means cosine is positive. Okay? Now, if cosine is positive, in our Cartesian plane, if cosine is positive, therefore, A must be in quadrant 1 or quadrant 4. Since in quadrant 2 and quadrant 3, cosine on those quadrants is negative. Since we have here cosine is greater than 0, which means that cosine is positive, therefore, A or angle A must be in quadrant 1 or quadrant 4. The other condition here is that tangent A is negative 2/3. So that means that tangent is negative, right? So in our Cartesian plane, tangent is only negative in 2 quadrants, and that is in quadrant 2 and in quadrant 4. So meaning the intersection of these two would be quadrant 4. So we are now sure that quadrant A is, or quadrant A, we are now sure that angle A is in quadrant 4. Now, let us proceed. What are we going to do next here? So, what we're going to do here is to draw that triangle on our Cartesian plane. And that triangle must be located in quadrant 4. Now, focus on here on this given, tangent A is equal to negative 2/3. So, it means that this would be the opposite and this would be the adjacent. So, opposite of A, so this part, this would become 2. And its adjacent would become 3. Now, what are we going to do next is to identify the hypotenuse. So, how are we going to do that one? Using the, you are correct, Pythagorean Theorem. So, the Pythagorean Theorem, that is the square of the hypotenuse is equivalent to the sum of the squares of the two legs. So, doing that one, so the hypotenuse now would be equal to the square root of 13. Another thing don't forget to do this one. Since we are on the 4th quadrant, meaning that this part must be negative. Now, let us proceed. We can now already identify the value of secant A plus tangent A all over secant A minus tangent A. We now have the value of tangent A. What we're going to do is to identify the value of secant A. So, secant A, that is the reciprocal of cosine, right? So, secant A is equivalent to square root of 13 over 3. Why? Isn't it that cosine is equivalent to adjacent over hypotenuse? Reciprocate that one, that would be the hypotenuse over adjacent. So that is why secant A is equivalent to square root of 13 over 3. Now, what we're going to do next is to substitute the value of square of 13 over 3 to secant A and negative 2/3 to tangent A. Next, simplifying this one. So this on our numerator, it would be square root of 13 over 3 minus 2/3 all over. On our denominator, that would be square root of 13 over 3 plus 2/3. Next, this one, our numerator, since we have similar fractions on both numerator and denominator, on our numerator, it would become square root of 13 minus 2 all over 3. On our denominator, it would become square root of 13 plus 2 all over 3. So, simplifying this one, we will have square root of 13 minus 2 all over square root of 13 plus 2. Rationalize the denominator. So, our answer now would be 17 minus 4 square root of 13 all over 9. So, again, if in case you forgot on how to rationalize the denominator, specifically, the denominator is a binomial that is with the use of the conjugate, you may again watch the video that I have uploaded about rationalizing the denominator. Down to our last example. So we have here if 3 pi over 2 is less than b is less than 2 pi, find B if cosine B is equivalent to sine 2 pi over 3. So, the given here is 3 pi over 2 is less than B is less than 2 pi. This means that this given is telling us the location of angle B. So if again, personally, what am I going to do here is to express those radian measure into degree measure. 3 pi over 2, that is actually 270, while 2 pi is 360. So we can conclude here that angle B is actually in the fourth quadrant. Next, let us identify the value of sine 2 pi over 3. So again, 2 pi over 3, what am I going to do here is to convert that one into degree measure. So sine 2 pi over 3 is the same with sine 120 degrees. Now, what's the next thing to do here? Identify the reference angle of 120 degrees. The reference angle of 120 degrees is 60 degrees. And remember this one, that sine, we know that 120 is in the second quadrant. And sine in the second quadrant is positive. So, we can say that sine 120 is the same as sine 60 degrees. Again, sine 120 degrees is the same as sine 60 degrees. So, what is sine 60 degrees? Sine 60 degrees is actually square root of 3 over 2. So, it's very important to remember the trigonometric functions of the special angles. 30 degrees, 45 degrees, and 60 degrees. Okay, 30, 45, 60. Next, so we know that sine 120 is square root of 3 over 2. So therefore, sine 2 pi over 3 is square root of 3 over 2. We can now say that cosine B is equivalent to square root of 3 over 2. So we need to find an angle. So based on our example, definitely this will be a special angle. So we're now going to identify the value of B. So what is that angle? That when you get the cosine of that angle, we will get square root of 3 over 2. Now, I'm going to present this table not to identify what is cosine square root of 3 over 2. Okay? Cosine B that is equivalent to square root of 3 over 2. What I want you to identify here is that, actually, on this table, you can already identify that cosine 30 is actually square root of 3 over 2. But that's not the reason why I show you this table. I want you to show this table to observe this one. Look at this one. Sine 60 and cosine 30, they are equal. Another thing, cotangent 30 and sine 60, they are equal. Another one, secant 45, cosecant 45, they are equal. Sine 30, cosine 60, they are equal. So what am I saying here? These are the trigo functions that are, if I may call partners, sine and cosine are partners, tangent and cotangent, they are partners, secant and cosecant, they are partners. Now, why am I saying this one? For you to identify what are the trigo functions that have equal values. So, if the angle add up to 90 degrees, then they would be equal. What do I mean by that one? Say for example, I'm not going to give us a special angle. Say for example, we have sine 40. Sine 40 is equivalent to cosine 50. Another thing, tangent 80. Tangent 80 is equivalent to cotangent 10. Another thing, cosecant 20 is equivalent to secant 70. Cosine 70 is equivalent to sine 20. So I hope that you understand what I mean when I show this table. Okay? So going back. Cosine, so we know that cosine 30 is equivalent to square root of 3 over 2. But B is not equivalent to 30. Why? Because of this condition. B is in quadrant 4. So what are we going to do here? So we're going to identify that angle wherein the reference angle of that angle in that quadrant is actually 30 degrees. So again, let me read that one. The reference angle of the given angle is B. So meaning the reference angle of B in quadrant 4 is 30 degrees. So try to recall that in quadrant 4, the reference angle is 360 minus the given angle. So in that case, we will have 30 degrees is equivalent to 360 degrees minus the given angle. Solving for the value of B here, B now is 330 degrees. So therefore, the value of B in this given problem is, just like what I've said, 330 degrees. So again, I always remind that in dealing with word problems in any topic in mathematics, you need to be familiarize yourself. It means that expose yourself to those different types of problems, and then practice. Keep on repeating doing those problems, and you will notice that it would be easy if you will encounter another problem that is somehow similar to that one. Okay? So with that, maraming salamat sa pakikinig and magandang buhay.